user doesn't really care much about hillside shadings. Like you don't ever need that as an input for computing something else. Hill shading is usually something that's produced, a map that is an illustration that you put into a report, that you put on a website, that you put on a flood warning system, something that the human end user can understand. If you have these, this is composed out of many triangles that are connecting up the points. And you can also change the display of those a little bit by changing the shading. The coloring is for points, but we made the points size 0. If you want to change the shading, there's also a command for that. But because I use the S command for something else, I use the H. Just think of shading, with a lot of pronunciation on the makes me. So I can click through different shading modes. This one is nice. I'm pressing H. Now this one looks funny. This is a wireframe mode. It's not really a shading mode, but it's part of the modes you get when you click through. And this is nice because you can actually see how the triangles connect up the LiDAR points to form this surface. In my case, you see these gigantic spikes, and now I can turn the points back on by pressing equal. Yeah, now you see these black points. What was black again? I never explained what black was. Black is unclassified. We don't really know what it is, so we didn't classify it. Here are the building roof points. Here are the ground, and you see how they have all triangulated up. The triangulation used here is the Diliman triangulation. It's triangulation done in 2D. It doesn't care about the Z coordinate, it just triangulates the points in 2D. And these don't look very nice, these spikes in the shading. This is part of, I think, of the power line, or something similar. This doesn't look natural at all. Maybe that's a good point to introduce something else. So imagine you really need to have this picture because your boss told you, I need a nice picture of my house, that's your boss's house, from the LiDAR, because then we can get DOSD to fund the project for 3 more years. Okay. Just an example, yeah? So I rotate this. Now you see the power lines. I'm rotating it. It's clearly the power lines here. Yeah? You can see the power lines now. It looks like an object on the ground that is way too high. How high is it? Well, so you see what I'm doing here right now is last view and ways to explore your LiDAR. So when you get the LiDAR, initially you want to do a lot of intuition, to understand what the data is. There's one option here. If you go with your mouse on top of a point, so I'm directly on top of it, it helps sometimes to make the points a little bigger by pressing equal. By the way, this equal, it's also documented somewhere in the menu. If you go to the bottom, point large, equal, point small, minus. So you can go on top of the point and press on the keyboard, press I. And now I don't because I'm missing half my screen. You will see the coordinates of that point.
X, Y.
X, Y, Z. It will say unclassified. I think it will say first. And maybe something else. So if instead I go somewhere down here, which is now on the ground, you know, I went straight down along this line, I'm taking a point out here from the ground, I do the same thing again, you see a different point. And now it should say, it doesn't say it for me because I don't see it, but on your screen it should say probably classification ground, and it should say different coordinates. And now look at the Z coordinate. Look at the Z coordinate. I mean, I'm not sure you have the exact same picture because it's not easy to get there. But just take two other points where one point is, if you don't have the power line in your particular view, maybe I quickly, before I go on, I'll quickly show you one more time how to get to the power line. So I press X, I'm in the overview mode. Yeah. I'm in the classification mode, so I can see the points as classifications. How do I do this? Well, you press C, 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 until you are here. Maybe your points are really small, like this small. So then you press equal, equal until they're bigger. And this house here has the power lines running right by it. You can see them as black dots. So just select an area like this, and then go back. This X. And why? Mine is already triangulated. You can untriangulate by pressing Shift T. Maybe that's what you see. And if you press T again, it's triangulating it again. So Shift T, that's like big T, capital T, and T. So now, as I said, your boss tells you, I want this picture, but I don't want the power lines looking like the wall of China right next to my house. Because, you know. But, by the way, you see that there's always a default mode. When you don't press anything, there's a default mode. Like right now, when I just do it, it's a zoom mode. You can change the default mode by pressing space. Then you go through all the different modes. In addition, by pressing Shift, Control, or Alt, you can always go to a particular mode. So Shift is always translate. It doesn't change the writing until you move. Control is always zoom. And Alt is always pan. So yeah, well, it's not really the wall of China because they won't stop anybody from walking through, but still. So last view, also it's called last view, is also a little bit an editor. And I don't do that very often, editing LiDAR points, but sometimes it's kind of useful. So let's try to get rid of these power lines at the house of my boss, so he can have a nice product presentation at the DOSD tomorrow. Yeah? How do we do this? Well, let's get rid of the triangulation. Shift T. So these are all the points here that I want to get rid of. There is an option called D. D. And now, and I don't see that because it says it right here. Delete mode. Or something like this. And you see how my cursor is now a crosshair. And no, it's not like you're going to shoot the points now, but you can now put a polygon around it. And whatever is inside this polygon will get deleted. Now, I wasn't very smart. These points are inside the polygon, and I certainly don't want to delete them. So if you made a mistake, you press Escape, and you go back 1 or 2 steps. Very easy. And now you place it again. I'm placing it right here, and then here. And that's good. So everything that's inside that little polygon, I can now delete if I think that's what I want to do. And you do that by pressing another key on the keyboard, and that key is R. R like register. Any better ideas for what R could mean?
Remove.
Yeah, but it's also used for another operation. It finalizes the operation. Like, so I pressed R, it tells me 36 points are deleted. And if I now press T again, make my triangulation, wonderful. Yeah, so the thing is gone. Now I haven't showed you yet how to save the new file. I'll leave that for another day. I just want to show you the option is there. We talked about DTMs and DSMs before. What you see here is more or less a DSM, a digital surface model. It means it's not uniquely defined. Different people have slightly different ideas what it means. A DSM usually means everything man-made is part of the surface. So houses, and also everything nature-made, like trees, is also part of the surface. And and if you and your dog walk along here, then in a way you would also be part of the surface. And a lot of people would argue yes, and some people would say no. But then you say, well, we say no. What about a car parked? Is that now an object that's there or not? What's the car that's always there because the tires are gone? It's not moving anymore. It's been there for 10 years. Is that not part of the DSM? So it's not really. Some people have different ideas what the DSM is. How about the power lines? They're always there. But if they're in the DSM, it looks like the wall of China. It's not here. It looks like a bunch of spikes, but if you have a more dense sampling, it can actually be like a wall. So the DSM is, I think, not uniquely defined. There are many small variations, but we can agree on it is, in general, the first thing the laser hits that you think could be part of the surface describing the Earth. The top layer, including everything on it. And since people walk around from here to there, they're not always part of the top surface at the same place. The ground surface, however, the DTM is much better defined. Not unique, but a little bit better. So if you press G, then you only select to display the points on the ground. Only the ground points. If I now press T again, it will triangulate only those points selected. And abracadabra, my boss's house is history. So now we have what's called the DTM. It's again hill shaded. If I go minus, 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 and it sort of looks natural here, but it looks kind of unnatural here. Why does it look so unnatural here? And that's some worse examples than that. That's because I don't have any information here. Because I just removed all the information. Because the laser does not go through the house, it stopped at the roof. And if I want the ground, which means no buildings, no trees, no cars, no dogs, no humans, no bicycles, no balut salesman. No, you love that. Yeah. But even the DTM is slightly different defined. So there are some people that want to remove everything that's man-made from the structure. But other people, in particular archaeologists, they say, oh, remove everything, but if it's man-made and close to the ground, then leave it. Like an old wall, or an ancient temple hiding under the forest in the Amazon River area. Because they want to see everything that's man-made on the ground, but they don't want to see all the vegetation above it. They want to, and there has been quite a number of exciting discoveries. For example, in Cambodia, they found out that the road network and the remains of temples in the Angkor Wat area, it was always known to be bigger, but they never could really show how big. And then they kind of could see where it was and actually proved that it was really a much bigger network than just Angkor, what's known as Angkor before. And other things with Samayan temples in Guatemala and so on. Okay, but now it's enough for today to take away. If I press G and T, I sort of get the DTM. If I press F, remember what F was? F? First return. If I press F, you don't see anything because the points are made size 0, but they're still there. If I press F and then T, I get the DSM. So if I triangulate the first returns, I get the DSM. If I triangulate the ground returns, I get the DTM. If I triangulate the last returns, L, I sort of get another DSM. And that's a common misunderstanding, and sometimes it's even taught wrong. The last return is not the ground return. Is not. Because the last return is right here on the building. The last return is right here on the tree. Now the last return is often the ground return. That's true. Often. In other words, almost every ground return is a last return. But not every last return is a ground return. And so if I now say plus, 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 and I make the coloring with C, then you see it's all the last returns. Last return is either single returns, or the blue ones. But if I get a single return from the top of the tree, it's the last return. First returns, triangulate. What usually happens is the trees become a little more volume when you use the first return. If you use the last return, you sort of cut up the tops of the tree to make a DSM. So most people use the first return to make a DSM. Also, then you have the problem with the wires. But yeah. Okay. Yes. Yeah.
How could you determine that it's the ground or not when you press the G? Do you have any algorithms for that?
Yes, and this is kind of what we're going to do in the next hour. Actually, we will be using a tool called LAStGround, which, if you have no idea what is what, it will figure it out. Hopefully, it's not always correct, but it's pretty often correct. And there are a few parameters you can adjust. One more thing I want to show. Let's look at another area here. So I shift, translate. Give a big hand to our friends from Cebu and Mindanao.
Can two of you stay here, please? Who wants to stay in front? Be the star people here. Come, two of you, please. Here, come. Yes, the other side. One, and on the other side, the others. So before the end. Thank you. Then we move to that.
All right. Okay, so we're gonna continue, and my assistant Charm is gonna take care of the newcomers and get them a little bit up to speed. All right. So one more thing I wanted to do is look at these points here. And I'm walking. I wanted to go to that big building. With the small screen, and it was a bit difficult. So I select the ground points and I triangulate them. I make them very small, and then I change the color, the shading mode, wireframe, and then I zoom a bit more in. Now, what do I see here? Anybody want to take a guess what I'm looking at?
Car?
Oh, excellent. Not pairs of shoes. Yeah, it's cars. It's a big parking lot. And right next to the parking lot is that big building that you can see here. That building. Yes, it's cars. They're classified as unclassified, because detecting cars is not really easy. But it's amazing the amount of detail you see here, right? I can even see where my sister parked her car. All right. So these are all the ground points. And you can tell it's a hard surface because there is no point anywhere in the middle. Because apparently there was no car with a hole in the middle. Now, you may be laughing, but there are some houses that seem to have a hole in the middle, where you find a ground point right in the middle of the house. Because when the laser goes, and the laser is about this wide, and I don't know about here, but back home we have a lot of chimneys. And sometimes the laser goes straight down the chimney, all the way to the ground. And then you have one, ground point in the middle of the... Cars don't have chimneys anymore. Move a bit over here, and triangulate again, ground points, triangulate again, triangulate again. So here you see I don't have, here's open field, so you see the laser scan lines, you can see them right on the ground, these scan lines of the laser. And here it was interrupted by vegetation. And there's some points in the middle now, but not all points came through to the ground. Again, I make my points bigger, and I color them. And then they are last returns of multiple, they are blue points. Here it's open field, single returns only. And under the vegetation, I'm under the tree here. It's only the last return that sometimes, not always, there's no last returns here that made it to the ground. see that this is a vegetated area. Okay, so much for the opening act. Now I do a bit more slides and then we do a first LiDAR processing. So there is the ArcGIS toolbox. If you like to use ArcGIS, there's in the ArcGIS toolbox folder, there are 4 different toolboxes by now. Here's just one. All the LAStools can be accessed, but they don't have all the options because otherwise the toolbox would have to be that long. But it's a nice way to start. You can also use the model builder to make larger models. You may have wondered, I talked about the LAS format, but then all we worked with was a LAZ file. Now, I used to do a lot of compression during my PhD, both during my free time, going diving and hiking, but also for my actual scientific research, I compressed triangle meshes. But nobody ever used that. So when the LAS format came out, I realized, oh, wait a minute, this is also geometry. I can compress that too, and there seems to be a lot of it, so it's worthwhile doing so. So I did that, and I wrote a little program called LAStools as an academic paper, and I submitted it to a conference and put it on my webpage. And of course, it was free. Academics, they do everything. At the same time, a company also came out with a product that also was compressing. It wasn't compressing as good, and it wasn't compressing as fast. It was decompressing rather slow, but it had an awesome price tag and beautiful magazines and brochures. Needless to say that nowadays nobody uses this compressor anymore. And the reason is not that LAStools is so good in compression and blah, 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 blah. The main reason is it's open source and it has a license that makes it easy to integrate into other software. So it's sort of free, but free like in freedom and not free like in beer. That's another topic to go. If you want to know more, there's a video on this. Here you see the lots of software now has native support for it, and there's a lot of LAZ data. A lot of people free their LiDAR data. They make the LiDAR data open in order to create an industry of innovation and to get the highest value out of the LiDAR data. Because a few people using LiDAR data, you get only a little bit of value out of it for the people. Because, especially if it's only government people using it, because they have a particular task, and that's what they're going to do with it, and nothing else. But if you open it up, like the National Land Survey of Finland, and then everybody who is passionate about anything in particular in their personal life and wants to improve that, and he's, oh, there's this LiDAR data that maybe can help me solve my problem. Like imagine you have a really old dog, yeah? But you like to go and walk your dog. Now you live in a hilly area. You could download the LiDAR data and then figure out an optimal path to walk your dog so it doesn't have to climb up and down very much. Now wouldn't that be nice? And you could do that. I'm not sure anybody did it for the old dog, but I know people do it for their mountain bike passes or for how can I get to school without much elevation gain or drop? Because then I'm not so sweaty when I get to school. So in the moment these people open their LiDAR data, I got a lot of requests from private citizens who just teach themselves this technology because they want to accomplish something. That's an added side effect. Your people educating themselves. And they come up with all kind of creative things. So there are now little companies selling maps for recreational maps. These companies wouldn't have existed. These jobs wouldn't have existed. And nobody would even have the idea to create this was not for the people that like to run through forests. And some of them are computer geeks. So by opening up the data, they would have never bought the data because the data, if you go buy it, you have to invest like $10,000, $20,000, $30,000, $50,000. So you don't even bother, you don't even start. You need to give it out for free in order to encourage people to start.